Alrighty, here's 8-8, day 1. We are going to focus on doing powers of complex numbers, okay, in trig form. Okay, still sticking with that. The big thing we did earlier in 8-7 when we first saw them, we multiplied them a little bit, but we did a lot of conversions of, got a rectangular form of the a plus bi to trig form and back. That'll still come up a little. But let's kind of, work our way towards a formula that would work for raising a complex number in trig form to a power. It really comes from multiplying 2, which in the previous lesson we saw that, and we did that. Because really, taking a power is based off multiplication. You're just multiplying the same number by itself. Okay? So from what we know about multiplying, we'd multiply r, and then we'd add theta. Okay, so we'd have r squared CIS 2 theta. Most of the examples we saw in 8.7, right, we saw that theta, if we're multiplying 2 different numbers, theta is not the same thing, right? It's not the same angle, and we had in our formula this notation for like theta sub 1 and theta sub 2. Not the case here because we're saying same number, okay? If we were to take a complex number 2, the third power, we'd be looking at this. R would be R times R times R. Theta plus theta plus theta. R, we'd have R cubed CIS 3 theta. Before we move down, take a good look at those. I think from seeing 2 of them, you're probably to the point where you could say, yeah, there's a pattern there. I think we could generalize this. So let's go to n. Because we saw 2 cases, right? One where n was 2, one where it was 3. Take r and raise it to the n power. Take theta and multiply it by n. You might have to double check to make sure that your angle is between 0 and 360 or 0 to 2 pi. I think everything on the next slide is in degrees. Okay, but same deal. You could subtract 2 pi if you're in radians to get back to the interval that you're supposed to be on. All right, so we're going to get a number converted here over to polar form. We'll graph it. We'll do a bunch of conversions, okay? Excuse me, we'll do one conversion, then we'll do a bunch of powers. We need to do a conversion to get started, though. All right, your number's right up here. A is a half. B is square root 3 over 2. Looks kind of terrible, right, with the numbers, but we're actually on the unit circle, so they come out quite nice. R is 1. Same thing with doing the inverse. In fact, let me just write it as tan inverse. B is square root 3 over 2. A is a half. We would divide those. It looked kind of terrible, but in not terrible, just not nice values for A and B. But again, they're on the unit circle. R is 1, theta is 60. When you put it into trig form, it's actually a nice little number. I'm going to switch the scale factor here to 1, so I'm going to work around the outside. That number's right there. All right, so Z is 1 CIS 60. Okay, we can just run through a bunch of these. You don't really see R change. Looking back on it here, I don't know if it was the best idea to pick one that has an R value of 1, right? Because as we square it, it doesn't change. Typically, you would see R get bigger and become a larger and larger value. Here we don't. That's okay. You still see the rule. There's Z squared. Here's Z cubed, and this would be 1 CIS 180, which would be there. What I'm trying to show you here again and again is just R, like whatever power you're finding, R to that power, theta times that number, right? We're doing Z to the 4th, so in this case, that number is 4. R to the 4th, theta times 4. One to the 5th, CIS 5 times 60, which is 1 CIS 300. There. And the last one we'll do here to the 6th. And that'll come out to be 360, but we would call that 1 CIS 0, and we actually end right back there. Okay. Now down here, I'm going to do this whole thing, but we're going to do it in rectangular form. Okay, we'd have some conversions to do here. I'm going to say 1 is right here. There's -1. Okay, there's the real, there's the imaginary. Okay, now I know, because I was given this one, there was Z in its traditional A plus BI form. Now, just as a reminder, because I'm not going to write this out for everyone, and if you wanted to convert these, a unit circle would be really handy. I got A from doing that. R times cosine theta, R sine theta to get B, okay? In fact, if you wanted to, so I got 5 more of them to get, squared, third, 4th, 5th, and 6th, okay? It's actually pretty, I mean, in this case, R is 1, so really all you need to do this is a copy of the unit circle and to know the process of how to convert, right? That's kind of what I'm after here, is a little more practice on converting back from trig form into rectangular, okay? We didn't do quite as much of that previously as I would have liked, okay? So now for Z squared, I'm looking here, and I basically just need to know sine and cosine at 120. This is where the unit circle will come in handy. There's cosine. There's sine. Z to the third would be 1 CIS 180. Z to the third is just -1. There's Z to the fourth, right? That's coming from right here. I'm looking at 240 degrees on a unit circle. What's the cosine value? That's A. What's the sine value? That's B. Z to the fifth, I'm looking at 300 degrees. Cosine is 1/2. Sine is negative square root 3 over 2. Z to the sixth, A is 1, B is 0. Okay? Now, keeping in mind as we do this, okay? I'm going to plot them on that graph right here. Square root 3 over 2. Okay, because 1/2, you're like, yeah, 0.5. That's fine. I can visualize that on the graph. Square root 3 over 2 is like 0.87. Okay, 0.87. Now, what I'm expecting with where these 6 points go is this, in their relative position, should look just like that. Okay. Z is 1/2. And then I go up, right? There's 0.25, 0.5, just over 0.75. So like kind of halfway in between those, right? There's Z. And just like up here, same spot as that Z. Negative 1/2. There's Z squared. Notice it's in the same spot as Z squared up there. Z to the third is -1. Same thing as there. Negative 1/2, negative square root 3 over 2. There's Z to the fourth, matches that one. 1/2 and then down. There's Z to the fifth. And there is Z to the sixth, matching up there. As always, right, both graphs check out. They match identically because I keep coming back to that to emphasize we're taking numbers, right? Complex numbers. We're converting the form that they're written in, okay? It's still the same number, right? Which is why whether you put on polar coordinates or on a rectangular grid, that number shows up in the same spot.